All right, thank you.
Come on, bring it on, bring it on. All right. Everyone hear me okay? Am I close enough to the mic? Okay. My name is Aaron Krauss. I'm going to be talking today about getting started with F#. This is going to be a super beginner-friendly talk. You don't have to know anything about F#. You don't have to know anything about C# either. You don't need to know anything. So we should all be on the same page. That's me. I'm the code boss on Twitter. I'll show this again at the end. So don't everybody get your phones on and start following me now. We can wait. I work at a company called Clevyr. This is our awesome gear logo. I'm here with my two coworkers, Nick and the other guy. That's John. We build a lot of data-driven applications. We kind of specialize in JavaScript development. We do Ruby too. We do Go. Historically, we don't do much .NET, but that's kind of changing pretty quickly now. I'm working on some .NET projects for some other companies. We're a consulting firm. There's a lot of what we do. But a cool thing we're actually doing now is just last week we created a new company called Clevyr Labs, and we're going to be focusing on working a lot with virtual reality and altered reality, augmented reality. And we're doing a lot of that with Unity, which uses .NET. So maybe we'll come back in a year or something and show off some of the cool things we've done. But Clevyr Labs, you'll probably start seeing that. If you follow Clevyr or me or anyone who works at Clevyr on Twitter, you'll probably see us talking about that a lot. Now I have a big disclaimer here. I'm not an F# guru by any means. I'm not a .NET guru by any means. Who here has done F# before? Okay. Whenever we get to the question and answer point, there's going to be a lot of questions that I won't be able to answer. And when that happens, I'm going to direct them to David here. So I'll just be the proxy. You think I'm joking, but I'm not. So with that disclaimer, you're probably thinking, like, why am I even giving this talk if I'm not awesome at anything, really, but either of these things. And it's because when we were thinking of talk ideas, at the little round table discussion we were doing, maybe back in January or December, I thought that I wanted to learn F# because I didn't know it before then. So I volunteered to give this talk. And I'm telling you this because I want to encourage all of you guys to, if you want to learn something, giving a talk is a super awesome and pressured way to learn something, which is not a bad thing. You know, you go to school, you go to work, you're kind of pressured to learn things there, and you do it, so it works. And it worked for me. So that's why I'm giving this talk. I wanted to learn F#, and now I have, and I get to teach it to you guys a little bit. Again, it's going to be very beginner-friendly, very surface-level deep, but I hope it grants you the knowledge to want to dig deeper, if it interests you. So about half of this talk is actually going to be talking about F#. The other half is going to focus largely on what functional programming is in general. You know, we're the C# group. We're not a functional programming group. We do have the OKC functional programming group, so if you found this interesting, I encourage you to check them out too if you don't already. They always meet the last Tuesday of every month at this location, same time. So because we're the first Monday of every month, it will always be, you know, the Tuesday before the .NET meetup. So if that interests you, check it out. They get way deeper into what I'm going to talk to you about, and I'm pretty sure everyone who's spoken there is much smarter than I could ever hope to be. So F# is it's kind of two things. That's the nice logo if you see it. It's a functional language. We're going to talk about that a lot. And it runs on the .NET framework. So it's kind of like C#. Well, first of all, it's kind of like Haskell, Erlang, Scala, Clojure, other functional languages. These are all functional languages. It kind of is like these, but it's also like C# and VB.NET. Before I get deeper, I just have a little fun quiz. A lot of times I throw t-shirts out, like this shirt right here. We're out of them right now, so I can't throw any out, but I still like to do quizzes. Does anyone know how C# actually got its name? Like why it's C#?
Sun Microsystems lawsuit so that it didn't become Java.NET.
I can't comment on those, but what I read was in music, and that may be absolutely correct. In music, a sharp note is, and I've read this from the actual documentation. In music, a sharp note is a half note above a normal note, and a flat note is a half note below. I think. I'm not a musician. This is what I've read. So C# is supposed to be, a higher level of C. A little fun fact. It was supposed to be called COOL a long time ago, COOL, standing for C-like object-oriented language, but that got scrapped for C#. The more you know. Okay, so F# is a combination of two things, the .NET framework and functional programming. Let's talk about the .NET framework first, because we probably are all going to be more familiar with that than functional programming. So we'll kind of blaze through this stage. So to run on the .NET framework, there's a few things that has to happen. I like to think there's more of an ecosystem too. When I think of a framework, I think of Ruby on Rails or Python's Django or Angular.js, like a tool. So I don't know. I think of it more as an ecosystem, but that's the name, .NET framework. So we'll keep calling it that. To be part of the .NET framework, you have to follow what's called the Common Language Infrastructure, CLI. There's going to be a lot of acronyms here. To do that, what that means is that your language gets compiled down into some kind of bytecode language called CIL, which is Common Intermediate Language. This is very similar to how Java works. It gets compiled down into something else. It's not machine code. It's kind of a platform-independent code. And this Common Intermediate Language will run on what's called the CLR, the Common Language Runtime. This is how all .NET works, whether you're using C#, VB.NET, F#, J#, X#, I don't think that one exists. And this is a lot of acronyms, so I think this image kind of helps a little bit. And again, I know I'm probably preaching to the choir here, but it's always good to have a little refresher. So you can see we've got C#, VB.NET, J#, F#. You can imagine is a nice little thing over here. There's some type of compiler that breaks it down into CLI, and then you have just the common language runtime, which is very similar to how Java's JVM works. It's just a virtual machine that runs this. Big benefits of this are platform independence. Again, .NET historically only ran on Windows computers, so obviously that was not the big boon. One of the big benefits of having the .NET framework built like this is that C# and VB.NET, J#, F#, everything, you can really integrate them a lot together because instead of having language-specific implementations, you can have things built for the .NET framework in general so that the CLR can just run it. Anyway, that's the overview of the .NET framework. A lot of us probably already knew that. F#, because it's kind of tightly integrated in this, there's a lot of things that we'll be using that are not F# specific. They're .NET specific, which means you can use them in C# or any other language. So that's how the .NET framework works. F# fits exactly into that. Let's talk about functional programming a little bit. And I'm going to spend quite a bit of time talking about what it means to be a functional language. And this is not F# specific. This is functional programming specific. So you can apply these to Haskell, Erlang, Elixir, any functional language. So there's kind of three core concepts that I like to break it down to. I'm sure another developer would tell you a different number, but I like to think of them as kind of three core concepts. And the first one, which is the main concept, is that in functional programming, you have pure functions. And what that means is that a pure function can have no side effects. And what you might think, what is a side effect? Well, a side effect is anything that, one, you're not intending to do, which is that's the vague answer. But what they really mean is it's anything involving modifying state. So you can't modify a variable that's defined outside of the function. That's modifying state. You can't read or write to the disk. That means you can't write to a database. You can't write to a file, anything like that. That's a state change. That's not allowed in a pure function. You can't print to the console because you're changing the state of the console. That's probably a very big red flag. If you're not familiar with what a pure function is, there's probably a lot of red flags coming up thinking like, how am I going to write any program at all using functional programming? And we'll get to that. It's a valid concern. But idea number two is this fancy phrase called referential transparency. Referential transparency. I think I just got smarter saying it. The easy way to think of it is anytime you have a function, foo, for example here, if you can replace that function call with the return value you get from that function, which let's just assume it's 8 here, then a function is referentially transparent. And you might think like, oh, that's probably most functions, right? Well, let's say that foo returned 8, but before it returned 8, it printed out to the console, hello world. Well, it's now lost its referential transparency because I can't just swap out 8 because I would miss that printing to the console. So that violates referential transparency. Another common thing that you might think about is you can't use anything random. You can't use a pseudo-random number generator because if I call this function foo and it returns, let's say, a random number, well, it's not referentially transparent. this violates one of the core concepts of functional programming. So let's just add no randomness to the stack of things that we just can't do. The last one are immutable variables. All variables you define in a pure functional language should be immutable. So don't really think of them as variables, think of them as constants. Again, another red flag, thinking, why would I ever use functional programming? And these are a lot of big things. Just to review, the way that I break them down is a pure functional language would have pure functions, no side effects, referential transparency, and immutable variables. There's certainly other smaller things, but these are the big three to me. And so why would anyone use functional programming? And one of the big reasons that's coming up, especially today, is the idea of concurrency. If you've ever, concurrency is just the ability to run multiple parts of your program asynchronously, kind of side by side. And if you've ever done this before, you may have run into some issues, such as if two parts of my program that are running asynchronously together, let's say they're changing the same variable, or they're writing to the same database table, or writing to the same file. That could be a big issue because you don't know what the other thing's doing at the time. They're kind of running in separate threads. So when you don't have to worry about state changes between functions, concurrency becomes a really simple thing. They just do what they need to do, and you can be assured that you're not modifying anything that is unsafe. So that's the big thing. Another thing is testability. If I know for a fact that function x is always going to return 5, and let me take a step back to referential transparency. I should say that the function foo, given the same arguments, will always return the same value. So let's say I pass in the argument 1 to foo, it can return 8. If I pass in 2, it can return 10. That's fine. It can be different return values, but for the same arguments, they need to be the same. Because you got to think, like, let's say we have an addition function that accepts two arguments, 1 and 2, for example. They're just going to add them together. That's a fully referential transparent function, even though it returns a different value with your different arguments. That's completely okay. It's super easy to test that, though, because you know what it's going to return. You don't have any setup. You don't have any teardown like you would in a stateful program. So it's super easy. And there's a design pattern called dependency injection that you can read about, where it kind of employs this functional concept of where you pass in your dependencies as arguments. So theoretically, if you're using dependency injection, this is not a functional concept. This is just non-functional concept. If you use dependency injection, you can kind of replicate the ease of testability, but it doesn't compare anywhere to how easy it is to test a pure function. And the last thing is, it's just plain simple. There's a lot of constraints, but you can't do much. You can do some cool things, but you won't have to. If you're ever modifying a pure functional language's code, you don't have to worry about what you're doing in other files. You don't have to worry about what the flow of the program is. You just have to worry about what's in this function, and that's it. So there's a lot of constraints, and a lot of those functional languages I listed earlier, Haskell, Erlang, Elixir, F#, none of those are pure functional languages, and that's because all these constraints make programming super difficult. I mean, think about it. If you could only write in a programming language that was pure functional, pure functions, referential transparency, and immutable variables, you could literally, if you ran a program, it would literally just be a function. You would know what your program is going to return whenever you ran the script to run it. That's how it would have to be in a pure functional language, and that's not really feasible for a lot of the things we do. You wouldn't be able to run a web server. You wouldn't be able to run any type of looping architecture, like if you were running a graphical application that has a main loop running. None of that's possible. So most functional programming languages, in order to actually be useful, they aren't purely functional. So it's more of a theory, in my opinion. I'm sure other developers will argue about that. And F# fits this exactly too. F# is not pure functional. If anything, these languages abide by the rules much more so than a non-functional language would, but they're not pure, and that's by design. You just can't do as much as you would think you might be able to in a pure functional language. So that's what functional programming is as a theory. So we're going to kind of come back to those concepts. So let's talk about F# a little bit, and we're going to do that with an actual demo. So I'm going to run into, let's see. Let's pop over here. Can you guys read this okay? Do I need to zoom in anymore? Okay. If I need to zoom in at all at any point in time, someone shout it out, and we'll zoom in. So we're going to show, and also another thing we're going to do is you'll notice I'm on an Apple Macintosh MacBook here. It's not a Windows machine. I'm going to be running the .NET framework using a Mac. So if you haven't seen this before, well, now you get to see how I would do it. And I'm going to do it through the command line too. We're not using anything Visual Studio, so you can just see how this would work. It's fully feasible. Okay, so we're going to jump into F# interactive. This is our REPL, read, eval, print, loop. That's just I issue a command, it runs it for me. So how do we define a variable in F#? Well, we're going to say let x equals 10. You don't have to do those double semicolons. That's just F# interactive, for whatever reason requires that. Okay, we've got our variable x. So, yep, there you go. We can see it's 10. If I want to redefine x, for whatever reason, it's not the equal sign. In F#, the equal sign actually means comparing. Like, if you do an if statement, like if x equals 10, that's what the equals means in F#. To actually assign it to a new value, we have to do the kind of backwards arrow like that. So let's say we want to assign it to 20. Well, it's not going to let us do that because by default variables are immutable. You can see kind of how F# is by default, applying some of these concepts. But all is okay. Another way that I can, redefine this variable, let's say I wanted to change it, I can just actually redefine it the same way I did earlier. And this is what's called shadowing. This is not an F# specific concept. We're just redefining the x variable to be 20. So while it's the same variable name, it actually is occupying a new space in memory. So a whole new variable, we're just shadowing the previous x variable. But we can do it a different way too. Let's say we have a variable y equals, let's just make it a string 10. What I can do is I can specify after the keyword let, but before the variable name, I can specify mutable. And all of a sudden, this variable is now a mutable variable. I can change y to be, 20. And there we go. If I print out y again, we change it to 20. So we've kind of learned about how variables work in F#. Let's talk about functions a little bit. And I'm going to define a function here. I'm going to open up a new pane. Oops, not that one. Let's open up a vertical pane there. Okay, I'm going to jump into a directory called code, and I'm going to create a file called add.f#. And now you're actually going to see me compile and run an actual F# script. Okay, so none of these files are really important. They're just kind of presentation files. Everything we'll be doing is going to be in this code directory. In fact, just to clear all that up, let me just jump in there. So we're just going to create a function, and it's very similar to how a variable works. We're just going to say let add. This is going to be kind of what I mentioned earlier. We're going to create an addition function. So this is going to accept 2 arguments. So we're just going to call those x and y equals. Now F# is a syntactically significant white space language, so white space does matter. It's like very similar to Python. Let's see, CoffeeScript, if anyone remembers that. It's one of those fun languages that compiles down into JavaScript. Okay, so we're just going to return x plus y. In F#, the last line of a function is your return value, very similar to how Ruby works, and I'm sure plenty other languages too. So this is all we need to do, and we can compile this. This is valid. We could give it, we're giving it 2 parameters right here. We could keep chaining on this. Anything we put after this followed by space indicates another parameter. So let's actually break this down into CIL. And the way we're going to do that is we're going to use the F#C command, which stands for F# compile. We're going to pass in add.fs. And there we go. It works. It tells us, though, the main module of the program is empty. Nothing's going to happen when it's run, which makes sense. All we have is a function there. So just to prove that, and what that did whenever I compiled it, it created add.exe. Well, I'm on a Mac, and Macs by default can't run exe files, so we're going to use Mono, which is the open source .NET implementation, and that's how I'm running all this code too. We're going to pass in add.exe, and it's going to do nothing because we didn't actually tell it to do something. So instead of editing this to do something, I'm just going to pull it into F# interactive. So I'm going to load that file. let's see. Oh, I need to. In order to pull it in, F# interactive only accepts modules, so I need to specify a module at the top here. So let's try that again. There we go, that looks better. So you can see our function got pulled in, and now I need to open that module. And now, if I want to add 2 and 3, oh, we get 5. So we just pulled in our function. So functions are, they function, no pun intended, very similar to kind of how variables do. They're defined in exactly the same way. So if you have a variable that just happens to have some logic, then bam, you just created a function. So let's jump back to this real quick. F# is statically typed, which makes sense, but you might be thinking like, hey, I thought statically typed languages always had to specify a type. And that's not true. That's a common misconception. The phrase statically typed only means that type checking happens at compile time, which compile time is whenever I'm actually running, the F#C command. So at this stage, whenever I'm building the file, that's when type checking occurs. Another thing is this is how we define a variable. Let x equals 10. I'm going to ask whether you think this is strongly typed or weakly typed. Who here thinks it's strongly typed? Who here thinks it's weakly typed? Okay, good deal. This F# is a strongly typed language. That's the answer. You can't tell anything by this about whether something is strongly typed or weakly typed. All you can tell by this is that there's something called type inference going on, because you're not specifying a type. F# is inferring the type for you. It's assigning integer to this. And you can tell that because in a strongly typed language, just to recap here, I've got an x variable, which is an integer of 20, and I've got a y variable that's the string value of 20. In a weakly typed language, if I try to add these together, there wouldn't be any error. It would most likely just combine it to 2020, because it would convert the integer value to a string. In a strongly typed language, it would throw an error, because you're trying to add an int and a string, and that's not going to work. So if we try to add in x plus y, it's saying, hey, strings doesn't match type int, and we can reverse that to y plus x, and we get the reverse message. Type int does not match type string, because our first variable was that y, which is a string. So F# is a strongly typed language, and that just means that it's got a higher degree of type safety than a weakly typed language. So that's just a fun little misconception I like to dispel every now and then. You can't tell anything about type safety right here. You just know that it's using type inference, because you're not specifying a type. We talked about that. The next thing I want to get into are this concept of higher order functions. One of the ways that functional programming does stuff is through the use of higher order functions. And what that means is for a function to be a higher order function, it can be one of two things. It either means, one, the function is accepting another function as an argument to it, which sounds confusing, or the function returns another function. Those are the two rules of being a higher order function. And this probably sounds confusing, but I feel confident saying you probably used some of these before. And this is not an F# specific concept. I'm going to show you how this works in F#. But there's three kind of key higher order functions that get talked about a lot in functional programming. And they're not specific to functional programming. They're specific. You can use these in any language, absolutely. But these are the ones that are used probably more often than the others. And they are, you've probably heard of some of them: map, filter, and fold. There's a good chance you've heard of map and filter. You may or may not have heard of fold. That one's a little bit unique from the others, but it's used pretty heavily. So let's dig into how these actually work in F#. Let's start off with map, the one you may be familiar with. So I've got some demo files here. If we go to map, we're gonna run through this, show you what it does. We've got a variable here. The quick brown fox jumps over the lazy dog. If you're unfamiliar, that's the sentence that has every letter in the alphabet in it. We're going to define another variable, which is a histogram. And before we get onto map, I want to showcase this cool operator called the pipe forward operator. If you've ever used shell before on a Unix-based computer, you've probably used the pipe operator. I imagine CMD has a pipe operator too, or at least some of the functionality of it. But what this does is we're taking this variable we have up here, breaking it into a character array. So we're taking the string, turning it into an array of all the characters. So you have T, H, E, space, etc. And then we're piping that to this right here, where we're grouping it using a lambda function here. So this right here is actually group by as an example of a higher order function, because we're passing in a function. This one's not doing much. You'll kind of see what we're doing with map below. These classes, seq and map, F# does not define these. These work because it's part of the .NET framework, and the .NET framework is where these classes have been defined. So kind of a cool example of how you can actually use, of how F# relies on the .NET framework. So we're grouping these up based on the letters, so we kind of have an array of arrays at this point. We're creating a map of those, and what that means right here is we're applying a function to it, and this is where the actual map comes in. We're applying a function to this array of arrays, and we're just passing in the key and value, and then we're finding out how long each array was. So let's say that the letter U appeared twice. We're just finding how often does, we're finding at this point in time, the array would, there'd be an array of U comma U. So we're just finding the length of that and applying it to U. So this is how map works. And then at the very bottom, we're just going to print this out. And we're not going to run this in F# interactive. We're going to run this just straight from we're going to build it just like we did our other script. So let me cd into demos here. Let me clear that. That's not a word. Okay, so we built our map file. We've now got a map.exe in here, and we're just going to run mono map.exe. And I'm going to full screen this so you can see it a little better. But well, still didn't see it all the best. But you can see, going back to the code here, we're iterating through each array and printing out how many times this letter appeared. So we can see the letter S appeared once, R appeared twice, E appeared 3 times. We can go all the way up. Space appeared 8 times because that's a character. So this is how map works in F#. If you're unfamiliar with it, the 3 core higher order functions are really good things to learn for any language. You'll use them quite a bit. So there's one more time. We're using map here to iterate through our array, and we're just applying a function, and all that function is doing is returning a number based on how often that letter appears in this array. And this right here is an example of an anonymous function. These are used in functional programming too, as well as many other languages. The only difference between an anonymous function and, I'm sorry, I keep saying anonymous, I think that's a JavaScript term. I should say lambda function, which actually derives from lambda calculus, which functional programming is based off of, the more you know. But the only difference between a lambda function and a normal function is that they're not named. So after this is used, this whole everything in those parentheses right there, I can't ever call it again. It's a lambda function as opposed to a named function like add, the one we just created. So this is how map works in F#. And you kind of got to see how the pipe forward operator works too. We're just continuing to pipe the data we get back into the next command. You'll see this a lot through the remainder of this presentation. It's a pretty handy thing that you'll see everywhere in F#. The next idea is filter. Filter works a lot like map, but the exception is that instead of applying a function to an array, to a list, I should say that map, filter, and fold all need to be done. The ideas behind them are you're modifying some type of enumerable object, something you can iterate through. So map iterates through them and applies a function and returns that. Filter iterates through them and applies a function again, but you're not modifying any values. You're just returning a true or false value. And if the value is true for this iterable, this particular item, then you're going to get a new array with that item in it. If it returns false, then that item is not going to be in that array. So a common example and kind of something we're going to do is if you wanted to have all the numbers from 1 to 10 and you wanted to filter out all of them that are even, so you get a new array with only even numbers, that's when you would use the filter high order function. So let's see how that works in F#. So the idea here is we're going to print just exactly similar to something I just said. We're going to take a list of all of the integers from 1 to 10, and we're going to print out only the even numbers, and then we're going to print out their squares too. So 2 will print out 2 and 4, 3 would print out 3 and 9, 4 and 16, 5, 25. Well, no, not 3 and 5 because we're only doing evens. 4 and 16, 6 and whatever 6 squared is, 36. Okay, so we're still going to use this map class because the filter method exists on that map class. And you can see we're still using pipe forward. So we we've got a list here. This is just very similar to how an array works. And we're returning a tuple. That's what these brackets right here mean. It's kind of just two values in this tuple. A tuple is very similar to how a set works. It can be just a list of values. So we're printing out I and I squared. So for example, it's going to be 1, 1, 2, 4, 3, 9, etc. We haven't done any filtering yet. And then here, we're going to iterate through this list, which is a list of tuples at this point. And we're going to print out the first value, which is going to be the 1, the number, 1, 2, 3, 4. And then it squares here. So you're going to get 1, 4, 9, etc. We are dumping this value because we don't need it for this. We're just going to filter based on if the mod of the first value is divisible. If it's divisible by 2, it's going to return 0. So that we're just specifying here if it's an even number, then we want to keep it. For numbers like 1 or 3 or 5, we're not going to keep those numbers. We're filtering them out because this function does not hold true. So this is a true or false function we're returning. And then we're just going to iterate through all of them and then print out the values of the tuple. So let's go ahead and run that. Let me shrink that back up. So as we would expect, we get a list of tuples, 2 and 4, 4 and 16, 6 and 36, etc. So we're only printing out the even numbers because we're filtering them out. So again, just using kind of what we did before, lambda functions, and we're just piping the result to the next actual line. So map and filter are pretty heavily used. Again, you may have seen these before. They're not too uncommon. The last one is fold, and this one's one of the ones that is going to take a little bit of explaining, because if you're not familiar with it, it seems like a doozy. But let's dig into. Let's open up the code first, and I'll start talking about it. Not map, fold. Okay, so the idea behind folding a function is you still apply it to an iterable, but let's say we have a list of the numbers 1 through 10, just like we did in our previous filter script. What you would want to do with a fold function is you apply a function and then you get a return value, and then what you do is you take that return value and send it to the next function call, which uses the next item in your list. So an example would be, let's say we wanted to add all the numbers up in this list, 1 to 10. One way we could do that, we could certainly iterate through them and just have a separate variable, add them all up. But we can use the fold function, and we don't need to define any extra out-of-scope variables. What we can do is we can, and we're actually going to do this right here. So, but what we can do is we can, start off. You have a base case. So in this case, it's going to be 0, and then we have the list of. We'll go with this example here. We've got a list here of 3 tuples. They're 1, the actual integer 1, and then a string 1. That's one of the differences between tuples and lists in F#. A list has to be, every value of a list has to be the same type, the same data type. Tuples don't care. So as you can see, this is an example of that. We've got an integer and a string and a tuple. F# doesn't care one bit. That's one of the big differences between them. So we've got a list here of 3 tuples, 1 in the string 1, 2 in the string 2, 3 in the string 3. And then here we're going to sum the first values of each tuple, and then here we're going to concatenate the second value, so the actual strings 1, 2, and 3, and we're going to do this using a fold function. So what we do, this whole line is a fold function, and we're going to take this slowly. We have fold is the function off of the map class, and it accepts 3 arguments. The first argument is the function that we're going to apply. The second argument is the base case, the very first value you want the return value to be, so that you know where to start from. And the last argument is going to be the actual iterable that you're iterating over, the list. So let's just walk slowly through this so we can see how this works. It's a lambda function. The function inside of the fold function, so the first argument of the fold function here, accepts 3 values. It accepts state, which is we define that. That's you can name it anything you want to, but that's just the return value that you keep returning to the next function call. So for the first time we run it, we're starting with the base case, which we've defined here, which is 0. So the state's going to start off at 0, and then key value. These can be as many arguments as you need it to be. It just happens to be 2 because we have a 2-item tuple that we're iterating over. So key here is going to be the actual integer 1, value is going to be that string 1, which we're not going to use for this fold one. So all we're doing here is we're doing just kind of what I was talking about before. We're just going to add them up. We're just summing up all the keys. So we start off with 0, which is state, and then key is 1, so that gets to be 1. And then the value of this gets returned as the state parameter for the next time we call fold, which we're going to call fold again on the next iterable, which is going to be this tuple right here. It's the next item in the list. So when we run it on this tuple, state starts off at 1 because that's the value that was returned from the last function. Key value is going to be 2 in the string 2. So we're going to add 1 plus 2, and we get 3. So the last time we run it, we only run it one more time because we have one last tuple in the list. State is going to be set to 3 because that's what it's aggregated to by this point. Key is going to be 3 as well because that's the first item of this tuple. And then value is going to be the string 3, which we're not using right now. So we're just going to add these up. So 3, which is state, plus 3, which is also key, that gets us 6. So let's go ahead and run this, and then we'll talk about this last one too. It's the same concept. So only focus on this first one right here. We still need to talk about that second item, but result is 6, and it followed the exact process I just listed. You just take, you start off with a base case, which happened to be 0 in this fold function, and then you just apply a function, and that base case gets incremented or decremented or whatever you're doing with it. It's the one that's getting modified. So if you need to do something like an aggregation of some sort, data aggregation, instead of setting a variable and iterating through a loop, maybe you can consider using a fold function next time. Different languages will call fold different things to make it even more confusing. Like Ruby calls it inject. I don't know why. But fold is by far the most common way that you'll see this function called. So the last list right here, it's literally the exact same code, except instead of using key all the time up here, we're using value, because we're going to add the strings together. Plus works on string too, because that's just simple string concatenation. In our base case, instead of 0, is just going to be an empty string. It doesn't matter what your base case is, as long as your fold function works with it, it can be any data type. And we're passing in the same list of tuples because we're just going to modify it. So starting off with a base case, it's going to be an empty string. We're going to take empty string plus value, which for the first iteration is going to just be the string 1, and then we're adding on a space in there so we can space out the words. So now our base case is 1 with a space after it. The next time we run, state's going to be 1 with a space. Key is going to be the integer 2, which we don't care about because we're not using it. Value is going to be the string 2. So we just concatenate 1 space and the string 2, and now we get 1 space 2, and then we add on another space after that. So 1 space, 2 space. And then you can assume that's also going to happen for the last iteration too. And you can see that we get here. So technically, this is actually, there's going to be 1 extra string here, right there, one extra space there, because we didn't have any case that said if this is the last iteration, don't do a space, etc. But you can kind of see how folding works. And the reason I want to harp on these so much is because these are language agnostic things. Even if you don't use F# from this day forward, these 3 higher order functions really will, if anything, they'll make you really understand, they'll help you understand how you can use data in a different way. But these are language agnostic concepts, really, really good to learn them. The last big thing I want to talk about, which works out perfectly, so we've got 12 minutes left, is how concurrency works in F#. That's kind of one of the reasons you might use F# is to use concurrency. One of the reasons why functional programming is becoming a big hot topic these days are because we're building computers that have more cores, not necessarily more processing power on those cores. I think this thing right here might have 8 cores. I think it does. So each of those cores are going to be a max of a gig, maybe a max of 2 gigs if I remember, something like that. But they're not souped up. There's just a lot of them. And if I run a Photoshop, for example, it's only using one of those cores. So one of the benefits of concurrent programming is you can utilize your system a lot better. In functional programming, like I mentioned, because you don't have those state changes, in theory, you're a lot safer doing those types of things. One thing I want to talk about too is, before I get into the code, is there is a difference between concurrency and parallelism. They're similar, but the key difference is that parallelism if your program is running in parallel, it is running on multiple cores. So if you only have one core on your computer, then parallelism theoretically won't work because it's just one core. Concurrency, you can actually run a program concurrently with using just one core, and it will do these things called time slices, where maybe this portion of your program will run, now, and then it pauses, and then you have the next portion of a program that runs, and it simulates, concurrent behavior. It is concurrent, but it's not parallel. You're just running it on one core. So, little difference there. We're going to talk about parallelism a little bit in F#. But in F#, the most common way to use kind of concurrent behavior is to use asynchronous operations. And what that means is that you're going to issue a command, and then you're going to wait for that command to come back and give you a callback. You're going to give it a callback of some sort, but while it's doing that, you're not halting your program from running. You're doing other things, and then whenever this service that you're querying, comes back with data, then you can use it. So this is the most common way to do parallel behavior in F#, and let's see what that looks like. This is going to be the last big code file. Where am I at? Async. Okay. Let me just get rid of that pain. Okay. A little bit more code, but it's nothing unbearable. You can see that's all it is down there. So we're including some modules because these are not going to be added by default. We have an array here, which each array is kind of a two-item list here. We've got a string of the website, and then the website here, Microsoft.com, Bing.com. I got this from the Microsoft docs, if you cannot tell. So we've got a function here called fetch async. I'm going to go to that in a minute. We have a variable here called run all. A function called run all. And then at the very bottom, we're going to do run all. So let's start off with this. We're going to issue run all. So that's going to come up here and run this function we defined. Well, that's going to take URL list, which, as you can see up on these lines right here, is just a list. And we're going to map. We're going to take these items and inject them into, or pipe them forward into the map function. And we're going to run fetch async on them. And we're going to apply. The reason this works is because the reason we're not specifying our arguments here is because we're piping in each item of the URL list, and that's why fetch sync gets these two arguments right here. One thing I haven't mentioned yet is F# will by default try to assume the variable type that you're passing in, and that's why you don't need to specify a type. If it can't do that, you can use these things called type annotations, which is where you can tell right here, we're just explicitly saying, hey, this is a string. And the reason you would do this are because let's say that let's say you're applying an operation that both an integer and a string can do, like the plus sign maybe. F# might. I don't think it will ever try just assume it's an integer or a string. It would just fail and say, hey, I can't tell what this is. You need to annotate this. So this is a type annotation in F#. And we're going to run an async block. And none of this actually will run until down further we have this run synchronously command. But before we get to that, let's talk about what will happen when we run async. It's going to run a try with command. This is synonymous with a try catch command in C#. It's an error, an exception handling block. We're going to just create a URI out of this right here. It's like the second argument in the list. So Microsoft.com, MSDN.Microsoft.com, etc. We're going to open up a web client, and then we're going to call let bang HTML equals async download this. Basically, we're going to query this web page and get the information from the web page. We could just run this, and it could block. We could just block the whole program if we wanted to actually send out a request to query the HTML on the web page and have it come back. But we're running this asynchronously inside of this block. I'm going to come back to why this is let exclamation point here in a minute, and then we're just going to print out, read this many characters from this website. If anything fails, we're just going to print out the message, which it shouldn't fail. Okay, so that handles this part of it right here. Then we have this async class here, and we're calling .parallel and .run synchronously on it. What these do are they accept an async block, which we're passing in right here from this function. Again, you can tell that for this function, there's no brackets at the end of it. There's no end statement. It's all just syntactically significant white space. So down here, whenever we start the command at the first indent, we're saying that this previous function is done. Async parallel, what this does, it accepts an async block and it prepares to run them in parallel. So it's going to take 3 async blocks here and it's going to run them all in parallel. But it doesn't actually do that until we have this run synchronously command right here. So we keep piping forward the async command, and then when ignore, that just ignores output. Don't know why this is called run synchronously. It makes more sense to me to say run asynchronously, but I'm sure the docs explain why that is. So we're going to run this, but the last thing I wanted to talk about was this let bang right here. By default, in an async block, whenever this command runs, it's not gonna wait for output. It's just gonna issue this request to download information from this website and keep going with the rest of your program. Well, we don't want that right now because our next line is we need to wait for this variable to come back in so we can set it. So our next line is actually gonna say, okay, we read this many characters from it. So we do want this to be blocking right here. But that's okay because these are in async blocks. So they're blocking, but only for those blocks that they're in. And we have 3 blocks going. So we've already, at this point, we've already defined that we're having, we have an async block defined for each item of this list. So we got 3 async blocks, and within those blocks, we are blocking. How many times can I say block? We are blocking inside of those async blocks, but again, that's okay because they're all running on separate cores anyway, because it's parallel. So that's it. Let's do a quick demo about that. What's that called? Async. And I do need Wi-Fi for this. It looks like I have it. So that's going to take a second. You can see they all came in at different times, but they weren't waiting on each other whenever they did. You saw Microsoft.com and Bing come in pretty quickly. So this is the most common way to do concurrent programming in F#. A lot of you may be familiar with how async programming works. If you've done any front-end JavaScript, that dominates how all of that works. It's also the bane of our existence, but it's a powerful tool. So this is the most common way to do concurrent behavior in F#, and I believe that finishes that. So we have successfully learned an F# today. So that's all I got. Again, very surface level deep. I think what Matthew was telling me today, that's he wanted to learn what a monoid was. We're not going to get that deep. Yeah, and this is as deep as we're going to go. So if you have any questions, again, I'll direct them to David. You can try to ask me. We'll see. But this is me. I'm the code boss again. Now you can get on your phones and follow me. This is my website, thesociety.org. I have a whole blog post over why it's named that. So I encourage you to read that. But I blog every month or so over topics that I want to learn about. So I think my most recent post was why random numbers are impossible in software. We only have pseudo-random number generators. I didn't know any of that before I wrote it, and now I do. So I'm happy. Okay, that's it. That's all I got. Any questions?